Hello everyone, welcome back to Coding Charms. This is fifth video in our sliding window pattern series. So far we have seen at the introduction of sliding window where can be applied. We have also solved some problems on constant length sliding window. We have solved one problem on variable length sliding window in our previous lecture. So if you haven't seen those videos, I would highly recommend to check those videos before watching this video, so you have a good understanding on sliding window concept. In this video, we are going to be solving the problem longest substring with k distinct characters. This is a medium tagged problem, and in this problem, we are given with a string, and we have to find the length of longest substring with no more than k distinct characters. So we can have at most k distinct or unique characters in our substring. We have to find the longest such substring. So in first example, we are given with the string ARR, AA, CI and k value as 2. And what will be the longest substring with no more than 2 distinct characters? Firstly, we have ARR, AA with length 4, and then we have AAC with length 3, and then we have CI with length 2. So maximum is ARRA with length 4. And here we are given with the same string and k value is 1 this time. So we can have only one distinct character in our substring. So it will be either A or R or AA, C or I. The longest is AA. So we return 2. And here we have CBB, EBI as our string and k value is 3. So we can have at most 3 distinct characters in our substring. So for it can be C, B, B, E, B, or else we can have B, B, E, B, I. The longest is with 5 characters. So it can be either CBB, EB or BB, EBI. We return 5. So let's see how we can solve the problem. Here I have considered the example with the string ARR, AACI and k value as 2. So what will be the naive or the brute force way of solving the problem? Let us first write down the string ARAACI. So in brute force approach, what we can do is we can generate all the possible substrings and find out how many unique characters are present in that substring. And if we have less than or equal to k distinct characters, then we can calculate the length of the substring and we can take maximum of such lengths. So let us do it. Let us see how it works. So firstly, we are at initial position and we calculate all the substrings starting at this position. So it will be AR, ARRA, ARRAA and ARRAAC, ARAACI. So we how to calculate how many unique characters are present in the substring? We can use a hash set and we can add all the unique characters present in our substring, and then we can take the length or size of the hash set so that we can get the how many unique characters are present in our substring. So in this case we have one unique character. So 1 is less than or equal to 2, so we consider its length. So far our maximum or longest length is 1, and now we consider this substring. This substring has 2 unique characters. It is still less than or equal to 2, so we consider it. We update the maximum length to 2, and we are at this substring now. ARA, the unique characters are 2, which is less than or equal to 2 or k. So we consider the length is 3, so we update our maximum length with 3, and here again we are considering this substring ARAA, and the number of unique characters are still 2. 2 is less than or equal to 2, so we consider the length. So the maximum length will get updated to 4, and we are here now. We consider this substring ARAAC. Number of unique characters are 3. 3 is greater than 2, so we don't consider this. and here we are at ARAACI. The number of unique characters are 4. 4 is greater than 2, so we don't consider this as well. And in the next step, let me delete this as well, and we move this to the next position. And now what we do, we consider all the substrings starting at this position R, RA, RAA, RAAC, and RAACI. We again calculate the lengths and we repeat the process till we reach to end of the string. We consider all the possible substrings in this way and we calculate their lengths, and then we check if the unique characters are less than k. In this way we do the process and we find the longest in the brute force approach. So what will be the time complexity? In order to generate all the possible substrings, the time complexity will be O of n into n, and then we additionally have to add all the characters in the substring to our hash set and calculate its length to find the unique characters. So it will add another n. Total time complexity will be O of n cube. So let's see how we can optimize the time complexity. We know that if we have to calculate or find something in a continuous subarray or a substring or a sublist, then we can use sliding window pattern. So let's see how we can solve this problem using sliding window pattern. And again, this falls under the variable length sliding window, because here we have to find the longest length of the substring. So we have to find the length of the window itself. So it falls under the dynamic or variable length sliding window pattern. Let me first write down the string ARAACI. So let us take it over here and let me write down the indexes as well. 0, 1, 2, 3, 4, and 5. In variable and sliding window problems, we usually have two pointers, the start pointer and the end pointer, to keep track of the length of the window and to keep track of what are all the characters present in the window, we keep a hash map. And in order to keep track of the maximum length or the longest substring, we keep track of maximum length variable, which is initialized to infinity, and we have start pointer and end pointer. So the length of the hash, we add all the characters in our current window to the hash map. So length of the hash map will be number of unique characters present in our window. So if length of the hash map is less than or equal to k, we expand the window. We try to get the longest string as possible, and if our length of the hash map is greater than k, we try to shrink. Because the current array is invalid, we try to get the string back to valid by reducing the window. So let's see the execution. So firstly, we are at 0th index and we add the character to our hash map A1. So this will be the character and this will be the frequency of the character, number of times the character repeats in our current window. And now the size of the hash map is 1. 1 is less than or equal to 2. So we update our maximum length. So this is the valid window, right? We update our maximum length by 1. And now we expand our window. And now we are at first position. The character is R. We add R to our hash map and add its frequency as well. Now the size of the hash map is 2 and length of the window is, to calculate the length of the window, we use the formula E minus S plus 1. 1 minus 1 plus 1. 1 minus 0 plus 1, 2. So the length of the window is 2. So this is a valid window because this is true. So we update our maximum length to 2, and now we again expand our window. Okay, wait, we have to take this end pointer. Now end pointer goes to second position and the character is A, so we update A's frequency in our hash map, and the length of the hash map is still 2. 2 is less than or equal to 2. We calculate the length of, so the window is valid. We calculate the length, E minus S plus 1, 2 minus 0 plus 1, 3. We got new maximum length or new longest sub array or substring. So we update the maximum length to 3, and again we move the E over here. So we are again at A. We update the frequency of A in the hash map to 3, and the length of the hash map is still 2. 2 is less than or equal to 2. Now our end pointer is at 3. So 3 minus 0 plus 1, 4. We got our new maximum length, 4. So we update the maximum length to 4. And now let me erase this. And now we expand the window. E goes here. Now we are at 4th position and the character is C. So we add the character to a hash map. And now the length of the hash map is 3. So 3 is greater than 2. Our condition failed. So now what we do? We try to shrink the window. So we move the S pointer by 1 position. What did we remove from our window? We remove A from our window. So we decrement the frequency of A in our hash map as well. So frequency will be 2. Now again we calculate the length of the hash map. Still the length of the hash map is 3 only. So we again try to shrink our window. Okay, we try to shrink our window. We move the S pointer. Okay, let me delete it and write it again. S pointer over here. And now we try to decrement the frequency of R from our hash map as well. So our frequency of R became 0. So we remove R from our hash map. Let me remove R from our hash map. And now the length of the hash map became 2. So 2 is less than or equal to 2. Our condition became valid again. So we again try to expand our window. So here our E will move 1 step forward and we are at 5. At 5, we have found a new character. We added to our hash map with the frequency 1. And now again the length of the hash map became 3. 3 is greater than 2. So our condition failed. Now we try to shrink our window. We move S pointer by 1 position and we remove we decrement the frequency of A in our hash map. A frequency becomes 1. Still the length of the hash map is 3. So again we try to shrink our window and we are at C now. We decrement the frequency of A frequency became 0. We remove A from our hash map. So let me remove A. And now the length of the hash map or size of the hash map is 2. 2 is less than or equal to 2. Condition became valid. So now we try to expand our window. So there is nothing to expand. So we reach at the end of the string. So we stop the execution and we return the maximum length. Maximum length will be the answer. So answer is 4, which is the string AR EAA. So what is the time complexity of this approach? The time complexity of this approach is O of the start pointer moved once throughout the array and the end pointer also moved once throughout the array or string. So the total time complexity is O of n plus n, O of 2n. So overall it's O of n. And what will be the space complexity? The space complexity will be, we are keeping one hash map. So the hash map can have all the characters. So the hash map can have O of n characters, or else we can say if it can have at most, if we are considering only lowercase English characters, we can have O of 26. But since it's not mentioned, let's take it as O of n or O of, we can say 256 considering all the ASCII characters. You can say O of n, or you can explain why it will be O of 256 in the interview. Or if they mention we only have lowercase English characters, then you can say O of 26 as the space complexity. Then it boils down to be O of 1. So let's code it up. So I have already coded up the main function with the test cases, and we have to implement the function get longest substring k distinct characters. Let's start. So first we have to calculate the length of the string given to us, string dot length, and then we should have the start pointer and the end pointer. Let's the end pointer start at 0 and goes till the length of the string and plus plus. We should also have the maximum length variable to keep track of the longest substring with k distinct characters, at most k distinct characters, and we should also have a hash map to keep track of the characters present in our window. Integer, let's say frequency equal to new hash map, and now what we have to do, we have to first expand our window. So let's take the current character as dot character at I, and what we do, we add it to our frequency map, frequency dot put c comma frequency dot get or default of c comma 0, and then we increment the frequency by 1. And now what we do, we check if the frequency dot size is greater than k. If it's greater than k, then we have to shrink the array. So we shrink the window. So we take, let's say, c equal to s dot character at start. So now what we do is, if we check if the frequency of the character at start is if it's greater than 1, then what we do frequency dot put, we decrement and we add it to our frequency map, frequency dot get c, we decrement the frequency, okay, frequency get c, and we decrement the frequency and we add it to our hash map. If the frequency is equal to 0, then if we decrement it, the frequency becomes 0 and we have to remove it. So we directly remove it from the hash map, frequency dot remove character, and then we update our start value. Now after getting out of this loop, our window will become valid again. So we calculate the maximum length, mat dot max of max length. We calculate the current window and see if the length of the current window is greater than the maximum window we have. If it is, we update the maximum length, and finally we return the maximum length. Let us run the code. It looks good to me, so let's run. Okay, character of I, this should be n, right? Let us run it. We have to get 4, 2, and 5. We got 4, 2, and 5. So that's all for today's video. And what will be the time complexity? The time complexity, as discussed, the time complexity will be O of n. The space complexity will also be O of n as well. So that's all for today's video. I hope you understood the problem and you are liking the sliding window pattern series. If you do, make sure you hit that like button, and for more videos, do subscribe to the Coding Charms YouTube channel, and don't forget to turn on the bell notification button so you get notified whenever I post such useful content. And see you all in my next video. Take care. Till then, keep practicing. Bye bye.